There are various ways to perform sentiment analysis: text block, Veda, bag of words, LSTM based models, transformer based models. So these are the various ways in which we can do. So text block, the first technique. Here I can polarity can be -1 to +1. Subjectivity will be 0 to 1, indicating if it is objective or subjective. It is easy to use, but it is not context aware. The next one is using Veda. It is a rule based technique, and here rule based with predefined lexicon. It uses the library NLTK.sentiment.Veda, and it can handle emojis, slang, capitalization also, but it has very limited vocabulary. Now, the next technique is using bag of words, ML models, and I can make use of count vectorizer, TFTF, IDF vectorizer, logistic regression. That is using ML models for sentiment analysis. It is good with small data, but it will ignore the word order and context. The next one is LSTM. Now, this LSTM is an RNN model, and so it's a sequential model. It remembers word order. It uses Keras or PyTorch. This will remember long-term dependencies also. It will know the word order, but it requires large data because it's a deep learning model. Transformers can be BERT or robot that can be used, and there are transformers from HuggingFace also. They are very good, but they are larger, slower, and they need GPU for best performance. So the movie was awesome. Today is Thursday, but I think it's a terrible Thursday. Now there are two sentences. So here the first one is positive, the second one is negative, and the subjectivity is both are subjective. Let me change this to, see here, subjectivity is 0. Today is Thursday, indicating that this is a fact but not an opinion. So here subjectivity, as you can see, it has come down to 0. Veda, I call Veda sentiment. From that, I get sentiment intensity analyzer. First sentence is: the book was a perfect balance between writing style and plot. The pizza tastes terrible. These are the two sentences. Now, first one is positive. So here, positive is 0.27. Neutral is 0.73. And then I have, for the second one, the pizza tastes terrible. Negativity is more, as we can see here. The next one is bag of words vectorization model, for which I should get finance data. I will import that data. So here I'm training the model. There are sentences and the sentiment around the sentence. So this is a confusion matrix. This has given me 7. There are 3 classes: negative, positive, and neutral. So here it has given me 70% accuracy. So if whatever are the sentences here, we vectorize them using count vectorizer, and then predict the sentiment for the new data. New predictions equal to MNB. Now MNB here, MNB is the model that I have trained here, and so based on that same model I predict the sentiment here. And depending upon that, it is showing me the result. So as we can see, it's fairly good result. Is performing well today. This could have been positive, but then it has been put under neutral. Again, there is a significant drop in the share price. This could have been negative, but it is put in neutral. So like this, there are various differences that are seen. Then LSTM, the next model is an LSTM, for which again we make use of finance data. Here, first of all, I am cleaning all the sentences, converting them into lowercase, removing all the digits. Lemmatizing the words, cleaning the words, and then after that label encoding the target. I put them into number 3 sentiment classes, and then training the model here. Then this is the model dot summary that it is going to print, and then it is going to, here model dot fit is taking time because I have specified 2 epochs, batch size of 32, and now it has reached this loss. And the accuracy, the test accuracy that we have finally got is around 65%. This is with the transformers. So from the transformers I get the model sentiment analysis, and then predefined models are got, and The model that I got is Federico Pico's QL fine tuning sentiment model 3000 samples. So when I give, I love this movie sucks. So here it shows me what is the score. Here it is a negative score, here it is a positive score with a surety of 95%, with a surety of 94%, the confidence of 95 and 94. Similarly, here also it was the best of times, it was the worst of times. The first one is a positive sentence, the second one is a negative sentence. So this is actually your model.summary should have been printed after train. See, now it has given me model.summary and the text accuracy. Text accuracy is similar, but I wanted to show that I can get all the parameters and all with the help of model.summary. So these are the 5 ways in which we can perform sentiment analysis: text block, wader, back of words, LSTM based models, and transformer based models. Further, we will see the theory about all these.